Okay, so function model selection. So in this lesson, they're going to give you a bunch of different things, and they're going to say pick a model. Okay, select a model. So can you look at number 1, bean, and can you look at the context and select an appropriate function to model the situation? So what would you guys do?
Linear.
Okay. What do you jump in and start doing right away?
Find
You do this?
Yeah.
Yeah, this is, okay. So, now, awesome. I feel like this has been drilled into your brains. It is linear because why?
Goes up by 5 every time.
So what would we say?
Constant. Constant rate change.
The first difference is constant. Okay, so did you notice how Kenrick said rate of change? That's fantastic too. So you remember when we were doing at the beginning, like the first couple quizzes, and it was like the rate of change is constant or the rate of change is linear, and that kind of just threw some of you for a loop because you're like, that's linear. Remember this? Because you were like, that's a linear equation, but the rate of change is not linear. The rate of change is constant. Does that make sense, like the difference? This one, if you do this next one, this goes up by 2, then it goes up by 4, then it goes up by 6, then 8, then 10. This has a rate of change that is linear because it's up by 2 every single time. Plus 2, plus 2, plus 2. And then if I keep going, I have a constant second difference, which makes this what? Quadratic?
Yeah.
Do you understand the difference?
Yes.
Okay. So constant means the numbers are all the same. And then linear would mean they go up by 2s or 3s or whatever. Okay, so try the next one. What do you get? I'll take attendance. This one you have to kind of be, make sure it's neat and you do your math correctly, don't you? Because if you mess up one tiny little thing, it just throws off everything. Have you noticed that? So you get 12, 18, 24, 30. So this is what? Cubic? Okay, this is cubic because the third difference is constant. Okay, so now, if you are presented with the next one and you just jump right in, okay, so when I was your age and all through college, I would just immediately go to the y values. I just always would do that. If you started to do that, you would get messed up stuff and it would never come out. Why?
You're missing 2 and 6.
Because the x values are not the same. So once you started that, you would hopefully realize, oh shoot, the x values are not the same. Okay? Because it goes 1, 3, 4, 5, 7, 8. Okay? So just know that if you go through and do this and it doesn't come to anything, that you probably should go back and look at your x values because you've done something wrong. Or you've done some wrong like adding or subtracting. So if we just get rid of 4 and 8, if we get rid of 4 and 8, then I'm going 1, 3, 5, 7. I have a pattern at the top, right? It's going up by 2, up by 2, up by 2.
You just go 3 to 4 and then 7 to 8.
Huh?
You could just go 3 to 4, 7 to 8.
Yeah,
Do that.
true. So what is this? 6, 6, 6. So this is actually linear because the first difference is constant and it's a slope of 3 because 6 divided by 2. Okay, so those are our main ones: linear, quadratic, cubic. Very, very rarely will they make you go to 4 or 5. Like, that's just a lot of work. Okay? So for these 3, you will see a lot of story problems. Do you notice this? A lot of story problems ask about volume or perimeter, and they give you weird like things. What is the perimeter of a pool? Okay. So perimeter. What do they usually say? I mean, they're not going to give you a question because you're an AP pre-calc. They're not going to give you a question with this labeled, is it? Okay? They might say, like, the length is 8 more than the width. Right? Have you seen that before? The length is 8 more than the width, so you have to do one variable. So what would my perimeter be?
2W plus
2W plus W plus 8 plus W plus 8. What's that? 4W plus 16. Fantastic. What type of equation are all perimeter equations?
linear.
Linear. Fantastic. Linear. So hopefully, if you're presented with something that says perimeter in it, you know that you are trying to make a linear equation. Does that make sense? Okay? You could graph it, maybe, to see things, okay? So this problem was, if you were more for like the seniors, remember in 8th grade, you had to find the tiles around a pool. I don't know if you remember that problem from those green books. Do you remember those green books?
Kinda.
Okay. So it said, I think the problem said, the inside is like a hot tub, and it is a 6 by 8 hot tub. Okay, all of the tiles around the hot tub are squares, and they are length X by X. So what would the area of the outside be of this hot tub?
Like minus the inside?
No, the whole thing. The area of the whole thing, like my total area on the outside. How much space do I need to clear off to build this? No. So you got to think of it. What's the length of this side? Because area is length times width, right? So what's the length of that side? Perfect. 6 plus 2x. Do you see that?
How did we get that?
So this in here is 6, right? And then we have an x, and then we have an x.
Oh.
I know, it's weird. Okay? And then same thing up here. If you think that this size is 8, and then x and x, so then that would be 8 plus 2x. So what type of equation is this? Quadratic. And you'll see on the next page, like when they are asking you about things on a quadratic, 99% of the time they ask for the maximum. So you're going to have to find like the top of the parabola or the bottom of the parabola. And then volume, I feel like everybody knows volume just because it's just kind of different, isn't it? Length times width times height. And they might do like x plus 6 times x plus 2 times x. So then you'd have to do it 3 times. That's going to be your most recognized cubic function, I would say. Wouldn't you guys agree?
Yeah.
Volume is like the one that we're going to use in everyday life. I want to know the volume of my 2 liter. I want to know the volume of my, whatever, 20 ounce pop or a soup can. Okay? Okay, so when 2 liters. 20 ounces, I know. Those are all. Okay, so, restricted domains. What does that even mean? Yeah. In real life, we have all restricted domains. We're not going negative miles an hour, are we? No. Okay? Our volume cannot be negative. Our perimeter is not negative. So, like, you have these specific domains. All right? So, take out your calculator. Can you plop this into your calculator? So, it says a bottle rocket. Ever shot off fireworks?
Ma'am.
Okay? Is set up on a picnic table. When the firework detonates, it will shoot straight up and come back down. The height of the bottle rocket is modeled by this. Okay, so we're going to go y equals and plop that in. Where t stands for time in seconds and h is height in feet. Okay, so if I just normally graph it and hit zoom 6, it looks really ugly, doesn't it? I can't find my maximum, okay? So here's where restricted domains kind of come into play. When you hit the window button, okay, this essentially is a restricted domain. Think about a bottle rocket. What's it going to start at on the x-axis for time? 0. How long do you think it normally lasts? 5 or 6? Let's do 6. Okay, go by ones. Y. How tall do you think a bottle rocket goes in feet? Pretty high. If we're like on average 5 foot. Let's go 0 to like 75. Yeah, it does go higher than 30. Hit graph. This is your goal. This is your goal, to get your parabola to be perfectly in your window. That's kind of like the whole reason of restricted domains. Okay, I don't need all that other stuff. That other fluff, I wasn't even using it. Okay, it's an actual bottle rocket. It starts 3 feet up, doesn't it? Because it's on the picnic table, but it lands on the ground. Okay, so think about it. What's H2 mean? X equals 2. So if you just hit trace, you can type in any number, 2, and hit enter, and it will go right to that point. Okay? Yes. So H of 2 is 67. What does that mean in this context?
At the highest. At 2 seconds, it goes up.
At 2 seconds, the rocket is what? 67 feet high. Okay, I am not, you are juniors and seniors, okay? I am going to expect that you can look up in the story problem and give me proper units, right? You can look back up and say, oh, that's seconds and that's feet. So you need to start getting in the habit of writing out sentences, because this is kind of like what you'll have to do on the FRQs. You'll have to write complete sentences with that information. Okay? So what's the restricted domain? Restricted domain. Well, I know domain are my x values. Okay? So if you look on my x, what is it going from?
0
to like
0, and we're not guessing, so we need to find it. We need to find
0, 1.
our other 0. So I'm going to go down. Okay, and we're going to round to 2 decimal places. So I got 4.05. 4.05. Okay, now you may see it like this, or you could do it as 0 is greater than, oh no, sorry. That's supposed to be an x. X is greater than or equal to 0 and is less than or equal to 4.05. These mean the exact same thing. And when I was looking at the quiz for this next section, they like did them in both ways. So just know that you might see both. AP Classroom might do it this way and this way, okay? They mean essentially the exact same thing. So what's the range? Range are the Y's. So what's my Y's? What do I go from what to what? 0 to 67. Yeah. Oh, no, 75 is like what I put in there, but the graph actually only goes to 67. Okay, what is the average rate of change? How do I find that from 2 to 3?
You plug in X for the 2 for X. and
Perfect.
2 for X, and then times
Yep, perfect. Or you can go to the
table.
table. If you go to the table, I see that 2 is 67 and 3 is 51. Or let's say when you're on your graph and they give you like 2.5. You could always hit trace and hit 2.5 and hit enter. And it'll give it to you, like if it's not on the table. Okay? And then you're finding the average rate of change. So 51 minus 67 over 3 minus 2.
Negative 16.
Negative 16 what? What's on the top? What are those numbers?
Feet
Feet.
for
And then what's on the bottom?
seconds.
Seconds. Fantastic. What does that mean?
It's going down 16 feet for 1 second.
Yeah, so because 2 is the peak, right? 2 was my max. So it's going down 16 feet every second. 1, 1,000, 2, 1,000 hits the ground. And then if I went to the other side, what would the other side be?
Positive 16.
Positive 16. Fantastic. Fantastic. Smart kids. Okay. Piecewise. Piecewise really just means it's pieces. It's not a continuous like sine curve or a parabola or a straight line. It's just pieces, okay? So this is a graph of generic high school yearbook. The yearbook sells for $40 for the first 5 months of school. After that, the price increases every month. So what does this mean? What does this mean? Can I go show up with $43.75 and pay for a yearbook? No, you wouldn't do that, right? Okay, what is this kind of telling you?
It has to be that exact price.
Yes, it's only that, and what's the prices?
$40.
40 and then
50,
50 and then
60, 70.
60 and then 70 and then 80. And then after 80, what?
Caps out.
Yeah, you are done. You can't buy a yearbook. Like it's just the sale is over. Okay? So, what's the domain in this context? Yep, so what would it be? So the domain is the x values. What are the x values down here?
0 to 5, 5 to 6.
So how would you represent that?
0 to 9.
And how would you do it?
Bracket.
Bracket.
9.
0, 9, parenthesis. Fantastic. Parenthesis, because when you go to 9, that is an open circle. Or if you wanted to be really specific, you could do bracket 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, parenthesis. Because it's just the whole numbers, right? But I guess in between, you could have one, wouldn't you?
You could buy it like a month.
You
from
could
now.
buy it in the month, in the 5.5, that's what it's doing down here. This is more for the next one. What about the range? These are your Ys.
40 to 85.
Is 40 included?
No. Yeah.
Yes. And what's the highest price?
80.
80. Okay? And that is a closed circle at 80 and an open, so we're gonna use that with our bracket. Or you could list them out, because really, this is the one where if you listed them out, it would make more sense, wouldn't it? Because you cannot pay anything different. You're not paying $55, you're not paying $65, you're not paying $72.50. Okay, you're only paying in whole amounts. And then fine 5.5.
45.
5.5, if I go up, what is it?
50/50.
So what does it mean in this context?
You pay $50 for the yearbook.
At 5.5 what months you would pay $50 for a yearbook. Perfect. Hi. No, I haven't done anything. Huh? Oh, have you? No, I haven't. Questions, comments, concerns, are we good?
Why is the 40 included?
What is this, you guys, what's like everything with them?
I know, it's good. Why is the 40 included? Because it's a solid line up into that point. So it's only not included after 5 months, but before that, it's $40.
Okay.
Yeah. All right. We are good. Now, my suggestion would be to get the homework done in the packets.